Okay, hi everyone. Sorry I'm not there today. I'm on a schism trip, but we can still do the next lesson so we don't fall behind. Okay, so what we're going to talk about today are annuities, which is kind of similar to the compound interest that we've been doing, but it's a little bit different. It's a little bit more complicated because what we're doing is we keep investing into an investment or we keep paying off a loan or a mortgage. Okay. So the majority of the time, when we invest or save money, or if we're paying off like a loan or a mortgage, we don't put it in as a lump sum. We put in a little bit. Okay, so it's either every week, every month, okay, or every quarter, maybe every year. Whoops, did not mean to do that. That's still there. Okay. Uh, for a second. I'm still scrolling. There we go. Okay. So loans, mortgages, and payments, or sorry, loans and mortgages. Are also repaid in regular amounts like weekly, bi-weekly, or monthly payments. Okay. So like a lot of times with the GIC, you'll just invest that once as a lump sum. Uh, but a lot of times what you would do is say, I want to put away $10 into my savings every week. Okay. But then as you put that $10 in every week, you still get the interest on it. Okay. So what we do then is use equations for what we call an annuity. Okay. And an annuity uh, is a annuity is a set of equal deposits or payments made at equal time intervals. Okay, so they're these routine investments or payments that we make. Okay, so if you buy a car and you have a car loan, every couple weeks you're going to have to pay off that loan. They won't just take your money all at the end. They want to see that you're going to pay it off consistently throughout the term. Okay. So that would be an annuity. Or if you're saving for post-secondary school next year, or one day when you get a mortgage. Okay. A mortgage is again you're paying off towards the interest, but if you're saving for your post-secondary, then if you put in like say $100 every month, and then that interest being added up every month, so you're making money on top of money on top of money. Okay. So the formula to calculate annuity, it looks complicated, but it's very similar to what we've been doing. It's most of the same variables. So it's A equals R times bracket, square bracket, then round bracket, 1 plus I, that's the I that we've been using, bracket to the power of n, minus 1 all over I. Okay, so we'll see that most of these things are actually things that we talked about. So A, again, is the total amount of the annuity, and this is the amount when it matures sometimes in sometime in the future. Okay, so say all we're talking about is the future value or like what your annuity is going to be worth one day. Okay, tomorrow we'll talk about annuities that you would have like right now, but for today it's just the annuity in the future. Okay, so R is the regular payment or regular deposit, whatever you want to call it, but just like the regular thing that either you're investing or paying off. Okay, so it's the regular amount that you're paying off as the investor. Okay, so just one thing to kind of note the way we calculate, just so that it's easier for us, the investment is always going to be made at the end of the interval. That's a lot better highlight than like the other ones. If fix those. Okay. Uh, really, that doesn't matter so much the way we do it, but like if you're working in a bank, then that would come into play quite a lot. Okay, because depending on when you invest, that's going to change the interest payment. So for our purposes, the investments are always made at the end of the interval. An I is the same I that we've been talking about before. It's the interest rate per compounding period. And I want you to leave this like we started doing, leave it as a fraction. Okay. Unless if you're just talking about like an annual payment, then For dividing by 1, we'll just leave the decimal is fine, but I want you to leave it as a fraction just so that we get a precise answer. Okay? And n is the number of deposits made by the investor or the payer. Is basically the number of compounding periods. Same thing. So, because it's the number of deposits that we're making, and the deposits are made at the end of the term, when it gets put compound, or at the investments are made at the end of each interval, which is when we're compounding it, it's the same thing as the number of compounds. So if you think of it that way, that's completely fine. Okay, so let's try some examples here and see that this big, scary equation is actually not that bad. Okay, so Luke deposits $500 at the end of each year into an account that pays 8% compounded annually. I want to calculate the amount of his investment at the end of 10 years. So again, remember, off to the side, I want to write down everything that I have. So I have $500, and if I go too fast here, just get the supply teacher to pause the video for you. Um, so Luke is depositing $500 at the end of each year. So that $500 is my regular amount that's being deposited. So R is going to equal 500. And then I also need I, which remember is my interest rate divided by the compounding period. So 8% has a decimal right here. Remove that 2 spots to the left. That'll be 0.08. And I'm compounding this annually. And annual just means once per year. So the I would be 0.08 divided by 1. So in this case, don't need to put it as a fraction because we're dividing by 1. It's not changing anything. I is 0.08. N would be how many compounds we have. So it's my time of the term, which is 10 years. 10. And I'm compounding once per year. So it's 10 times 1, which would just be 10. Okay. So now I get to sub this into my big, scary equation here. A is equal to R square bracket, round bracket 1 plus I bracket N minus 1 square bracket all over lowercase I. Okay, and now I'm just going to sub in all my numbers here. So R is 500, so I have 500. And then I'll have my square bracket again. Bracket, this one doesn't change, but then I have I, which is 0.08. 0.08 to the power of n, which n was 10, minus 1 square bracket all over 0.08. Okay, and now you can type this all into your calculator at once. Okay, so you don't even, if you want to do it step by step, you can, but it's easiest just to type this in as you see into the calculator. What you might want to do is sometimes you just might have to put an extra set of brackets around the numerator. Just make sure that your calculator actually does the numerator first before you divide by the 0.08. But if I plug this into my calculator, I'm going to get my total amount is $7,243 and 28 cents. Okay. So this actually isn't pretty bad. He deposits $500 once a year, and at the end of 10 years, he's going to have 7 grand. Okay, so that's not too shabby there. Okay, let's try another example. Ray is saving to buy his big screen TV. At the end of the month, she deposits $500 into a savings account that pays 6% compounded monthly. How much has she saved after the first year? Okay, so the other thing I'm going to kind of show you here is that um, each year, oops, that's not what I want to do. Do that. My highlighter here. So Luke deposited at the end of each year. So he's doing it once per year. Ray is doing it each month, and she gets her interest to compounded monthly. These numbers are or these time periods are always going to match up to each other. Okay. Just that way we don't need to get to any more complicated formula. So just if it's compounded monthly, the regular payments are being made monthly as well. Okay. Just one thing to keep in mind for you. Okay, so I'm looking for the amount, so I'm going to need a regular payment amount, which looking here, the only kind of currency I see is 50. So my regular amount is $50 every month. Okay, then I is equal to 6%. Move that over to decimal spots, so 0.06. Then I divide by my compounding period monthly, so it gets compounded 12 times per year because there are 12 months in a year. And then how many times does Ray make the investment? Well, we're just looking at the first year. So I'm just looking at 1 year times 12 investments. So my M will be 12. Okay. So now let's get the big formula. I'm going to zoom in a little bit here just so I have more space to write. A equals capital R bracket. And again, like all the other formulas for this unit, is that right? Plus one for the last one? Oh, yeah, okay, good. Like all the other formulas for this unit, you will not have to memorize this. I'll give them to you on the test and on the exam. Okay, so I should just roll over a little bit so I have all my variables here on the screen for you. So my regular payment, my R, is 50. Square bracket, round bracket, 1 plus I, which I'm leaving as a fraction, remember. 0.06 all over 12 bracket to the power of n, which is also 12 in this case, minus 1 square bracket all over 0.06 divided by 12. Okay, and for this one, remember if you're typing it onto your calculator once, which I recommend, it's going to usually it's going to work out easier. And that's why I really want you all to make sure you have your calculators, bring them to class so that you know how to use it, so that on the test it's easy. Okay. The hardest part for this unit is all the stuff in green on here on the side. And taking out the information from the test, subbing it into the formula is that easy. Okay, but R is 50, so we had R, you put 50 in there. I is a fraction, put I in where the fraction was, and then where M is, and then just punch it into your calculator. Okay, so make sure you get a good calculator and you know how to use all the buttons. Okay, because your answer should equal mine here, which will be 600. Oh, yeah, forgot the dollar sign here. $616.78. So if you don't get that, you need to try again on your calculator, uh, or we can go over it tomorrow. I can show you how to input it onto your calculator. Just make sure you get the right answer. Okay. So Ray, at the end of the year, she has $616. Not a bad chunk to put towards the TV. She might just start saving a little bit more. Okay, next example. The Campbells are saving to buy a house. Okay. Maybe they just moved to the New England area, so you gotta buy a house. They deposit $1,000 at the end of every quarter into an account that pays 7% compounded quarterly. How much is in the account after 4 years? So right away, my dollar amount, I know that's my R value. Okay, that's the regular payment that's being made. So R is 1,000. I is the interest rate per compounding period. I always have to look for the percentage. Okay, move that 2 to the left. So I get 0.07. all over my compound period. Uh, they deposit at the end of every quarter, and it's compounded quarterly. All my units are matching up. So quarter, remember that breaks the year up into four parts. So it's being compounded. Whoa, don't need the highlighter anymore. I need this. Being compounded four times. So 0.07 all divided by 4. N will be equal to how many deposits that they're making. Uh, it's 4 years. So 4 times the 4 compounds per year. So there'll be 16 deposits for them into this account. Okay. Whoa, don't want to do that. Scroll this over a bit. Come back. There it is. Okay. Uh, we have A is equal to R times bracket 1 plus I power of n minus 1 all over I. Sorry, I kind of went off on an angle there. So again, sub in the R value, 1000. Let's keep the colors coordinated here. 1000 square bracket, round bracket, 1 plus 0.07 all over 4. Now this would work out to a decimal where you wouldn't have to keep like 18 decimal places. So you could use the decimal, but just for the sake of habit, I want you to keep the I in terms of a fraction. Just get practice with it, okay? 0.07 all over 4. So I have 1000 times 1.1 plus 0.07 divided by 4, all to the power of 16 minus 1 all over 0.07 divided by 4. Okay? And then this one big equation, but you can sub it into your calculator all at once because it gives you the most exact answer you could get. And we're going to have $18,281.68 in the account. Remember, we always go to two decimal places for this unit when we're talking about money because we go down to the cent. Okay, so for all these, what we've been doing is calculating the total amount of our investment in the future. Okay, so what's this investment look like? But sometimes I want to know, I want to have like a goal. I want to say I want to have this much money in this time frame. How much do I need to invest? Okay, so sometimes we want to know how much to invest for the regular deposit. So if I take this equation and rearrange for R here, I'm actually doing is kind of moving the I over first, so that's going to come up and multiply. Then I take all of this and just be multiplied to R and divide it. So what the equation becomes is R equals A times I all over that big square bracket I had before. 1 plus I to the power of n minus 1. Okay, so again, you wouldn't have to memorize this formula either. It's the same formula, but we're just rearranging it for R instead of A. Okay, so this time I'm going to try and find what the regular amount that I need is, and I'll be given the total amount that I want at the end in the future. Okay, so an investor wants to retire in 25 years with $1 million. Her current investments are earning on average 12% compounded annually. So what regular annual deposit must she make to have the required amount? So this time I know A. A is always the big number. So A is $1 million. Okay. Then I should know I too. I have an interest rate here. Be careful when you're moving the decimal. A lot of people the other day call it 0.012, but I only moved the decimal over 2 spots, which means that it would be 0.12. Okay, and it's being divided by my compounding period, which is annually. and it's an annual deposit that I'm looking for. Annual just means 1, so I divide this by 1. So for this one, I don't care about the fraction ju- because 0.12 divided by 1 is still 0.12. Okay. And then lastly, I'm looking for how many deposits are there going to be. She's looking at a 25-year term times once per year, which would just be 25. Okay, so now I can sub this into my new, uh, well, kind of new-ish equation. Keep this on the screen at once, right? Perfect. I'll zoom in a little bit. R is equal to A times I all over 1 plus I to the power of n minus 1. Okay, so A is 1,000,000. 3, 4, 5, 6. There are 6 zeros in a million. Times I, which is 0.12. Oh, that's not. Why did the color not change? Times square bracket, round bracket, 1 plus 0.12 bracket to the power of n, which is 25. All minus 1. Please do not forget about that minus 1, otherwise it's going to mess up your answer. Because when I punch all this into my calculator, remember, I just made some more brackets up there, but my regular payment amount will be $7,499.97. So realistically, she should just round that up to 7,500. But that is the actual amount that she would need to invest every month in order to, or sorry, every year in order to get $1,000,000 at the end of 25 years. So let's say uh, B asks how much of that $1,000,000 is interest. What I want to do here is find out how much this investor actually invested, how much money she put in every year, and then I'll subtract that from the total amount to find the interest. Okay, so what I want to do first is find out how much total money she paid, which would be multiplying my 74,900 or $7,499.97. And I'm going to multiply that by actually, what I'm going to do first is do, nope, I'm going to take R and multiply it by N. Okay, because how I'm going to see how many payments she made or each payment amount and multiply that by how many payments she actually made. So it'll be 74,999.97 times 25, and that will be equal to 1,499.25. Okay, so this is how much she paid over the term. So now to find the interest, I'm going to take my amount and subtract it from this value, which was R times N. Okay, so my total amount, because she's going to end up with $1,000,000. So if I find out how much she put in and subtract that from the $1,000,000, whatever's left has to be the interest. So $187,499.25. So how much of this money was interest? It was actually the majority of it. 812,500. and $75 was interest. Okay. So I know you guys are young, you're not even thinking about retirement, but when you start working, look at making investments because you can make a lot of interest through kind of minimal payments. Well, not minimal payment, that's a big payment of $75,000 here, or sorry, $7,500 here, but it does add up quickly to make you $1 million. Okay. And most of that becomes interest. So that's it for today. If you have any questions, we can go over it tomorrow. But for the rest of the class, there's just a worksheet. Try giving that a try. And if you have any questions, we can take them up tomorrow when I'm back. Okay. Have a great day. Bye.